Hi, everyone. I hope this finds you doing well and staying healthy. Kind of a quick related aside. If you hear me clearing my throat or coughing, I'm going to apologize in advance. It's just seasonal allergies, just from some pollens that have blown in. Hopefully, it won't affect my speaking throughout this demo, but just want to let you know if it does. I haven't come down with anything worse than seasonal allergies, all good. So I wanted to circle back around on the topic of Salesforce Functions development in Illuminated Cloud. A few weeks back, I posted what I called at the time an early days video, really just showing some ideas on how that integration would work. And the focus was really on the capabilities of the base JetBrains IDEs and their support for the various languages that are supported for Salesforce Functions development. And I kind of hand waved what the Illuminated Cloud specific integration points would look like. Well, in the intervening weeks, I've made very good progress on that. In fact, I've basically built out, I think, this demo will show to be a very compelling end-to-end feature set for Salesforce Functions development integrated into Illuminated Cloud and its existing Salesforce development features. And this will be almost more of a tutorial, not only on how to do functions development in Illuminated Cloud, but also on what functions are. I think that these are obviously going to be new to people. You may have seen some of the existing demos. You may have played with this, but there's quite a bit to learn. And it's quite different from what has come before in the Salesforce development ecosystem. So with all that preface aside, let's go ahead and jump in. The first thing that I need to do is just create a new project that is equipped for Salesforce Functions development. Now this needs to be a Salesforce DX project because the CLI is used for pretty much all the lifecycle operations for functions development. And again, you'll see that as we go through the demo. So we'll just go ahead and create a new project called Functions Demo. And I'm actually going to do this based on the empty template just to keep things simple. And so we'll go ahead and just create this project and let it be created right here in place in this window. And then the next thing we'll need to do is create or choose an org. Now I'm going to create a Scratch org, and part of that is to show you how you need to set up your Scratch org for functions development. So we'll go ahead and call this the same thing. And the only other thing that I need to do is go down here to features and choose this new functions feature and enable that. And we'll go ahead and let that be created. Now, if you're not working with Scratch orgs, obviously you'll need to be working in an org that has this feature enabled. If you are working in a Scratch org created off of a dev hub, that will affect one step a little bit later on. It's when you authenticate effectively to the function system. You will authenticate to your dev hub using your dev hub credentials instead of to the Scratch org itself. And again, assuming that step comes up, I don't know if my credentials have timed out, so it may not come up in this demo, but assuming that comes up, I'll explain more when we get to that step. So I'm going to go ahead and just choose that Scratch org I just created, and we'll go ahead and let the project be configured for that and let it generate the offline symbol table. And while that's generating, what we'll do is go ahead and first show that there's nothing function specific going on at this point. You don't see any source code for functions. It's basically just the stock standard empty template that was created for a new Salesforce DX project. So what we'll do is move down here and look at this new tool window that's been added. I alluded to this in the previous demo saying that this is probably how it manifests, and in fact it did, called the Salesforce Functions dashboard. And this is going to be really the primary user interface for lifecycle management of functions. Now for standard development of functions, that'll happen in the base IDE features, the editors, the debuggers, things like that. We'll go ahead and skip this. But for actual creation and removal of functions, for deployment of functions, for local execution or for remote execution, for monitoring, that's all going to happen right here. And so why don't we go ahead and dive in and create our first function. So I'm just going to say new function, and there are 3 different languages. We'll go through each of these in the demo. So I'm going to go ahead and create one in Java first. So we'll just call this Java function. There are some restrictions on your function names and IDs. That's actually all called out pretty clearly here, and it'll validate if you don't follow those conventions. I'm going to name the Java class something really simple, Java function. This is going to be the implementation of the Salesforce function interface. I won't change the description now. I'll show you how you can do that in just a moment, just to give an idea of the layout of a generated function. And I want the IDE to actually format the generated files according to our project's code formatting standards. Okay, so it's created that function, and a function is not just a single file. I'm going to bring this down. It's actually a directory structure. And so now it created a new top level. This was the CLI that did this, to be clear. Illuminated Cloud engaged the Salesforce CLI with the new functions commands to do this. And there's a new top level directory called functions, and under it, a subdirectory per function. And within that, the structure will differ based on the implementation language, but basically you have the source code for the function, unit test for the function, and then some of the scaffolding for it, including things like a dependencies definition file. And that dependencies definition will be for Maven for Java-based function, and for JavaScript and TypeScript, it's going to be using npm in a package.json. Now, I'm going to just real quickly talk about this. You'll see some of these pop up. As you can see, this is not in Illuminated Cloud. I've reported a few of these things to JetBrains about some errors that are occurring in some of their standard plugins. I'm going to ignore those for the rest of the time and just keep moving on. But I didn't want to just have a big red box come up down there and not actually address the the elephant in the room, so to speak. Okay, so we have our Java function here. It was generated, like I said, it just implements the Salesforce function interface, parameterized by an input object and an output object, and basically those get serialized or deserialized JSON respectively for the two endpoints of the function invocation. And so what else was generated? Well, we said that there's a unit test. So let's take a look at that. So here we have a unit test, and if we, how about we actually find usages on this? Here we have our unit test. We want to find it over here. It's right there. And it's automatically configured properly for an IntelliJ IDEA project. If you're using something other than IntelliJ IDEA, you can build Java functions, but it's going to be very limited in what you can do. And then conversely, if you're not using IntelliJ, I'm sorry, if you're using one of the free IDEs like Community Edition, you'll be able to build JavaScript and TypeScript functions, but again, you're not going to have full IDE support. So for this, because it's so involved with the base language, it's going to be recommended to use a JetBrains IDE that supports the language of implementation for the functions you're creating. Okay, so we have our unit test here. It's very easy to run this. This is just functionality that is provided by the base IDE, nothing that's been created by Illuminated Cloud here, other than kind of marshaling things back and forth with the CLI to make sure things get generated and set up properly. And so that just ran the unit test. Obviously, those will be fleshed out. As you'd expect with the unit test, let's look at the actual function implementation itself. All it does is queries some account records and then marshals those back as its output. And one thing I will point out is there is specialized support here for when you write queries in your function. It's not in Apex. These queries are occurring in Java or JavaScript or TypeScript, but nonetheless, it is automatically injecting SQL into, let's see, it is automatically injecting SQL into the string literals in those languages so that you get full code completion and validation. For example, if we put account X, it's going to show that that's invalid. So you don't necessarily need to just be working with an opaque string literal when you're writing these queries. That's actually live authoring, and there's some other places where that'll come into play too. But this one's just querying some accounts and marshaling them back. So not much going on here, but as you would expect with a unit test, it's mocking all the externals. So you can see when query gets called, mock up a result set. So this actually isn't talking to Salesforce. This is a true unit test isolated to effectively validation of your logic. And then you decide how to mock up the inputs and outputs for externals to validate how you respond to those particular inputs and outputs, how your logic does. But what happens if we want to instead see how our function executes in an actual deployed environment, communicating with Salesforce, effectively integration testing against it? Well, in that case, we have to deploy it. There's really two ways to deploy it, and for that, we're going to go back to our Salesforce Functions dashboard. So we can see where we created this function that we now have additional information about it, and we can see that there's local execution and remote execution panels here, as well as tabs, and we're going to go into each one in detail. Let's start with local execution. For local execution, what is going to happen is it's going to deploy your function into a local Docker container. Now, if you're not familiar with Docker, it's a way to run managed virtual machines locally, very thin, what are intended to be very thin virtual machines. It's a wonderful technology for doing really kind of compartmentalized distributed computing. And if you don't have Docker installed, Illuminated Cloud will recognize that and will provide instructions on how to get it installed, but that's going to be a prerequisite for doing functions development and wanting to do local execution. Now, if we want to actually do this. In this case, I have Docker desktop installed on Windows. If we want to do this, we can just come over here and say we want to start this local Salesforce function, or we want to start it and immediately connect a remote debugger to it. And we can also, if we didn't connect the remote debugger, we could connect it after it started. We can restart it if we have implementation changes, things like that, or we can stop it if we have it running. We'll do some of those in a moment, but I want to show what will probably be the most common way of doing this, which you may have noticed already that there's a gutter icon here on this implementation on both the class that implements the Salesforce function interface and on the primary method of that interface, the implementation of it. There's a gutter marker that effectively it denotes this as being a Salesforce function, and we can actually just click on that and we can run our debug right here, or we can modify our debug configuration or our run configuration. If we want to modify it, the main thing that you're going to be changing here is the payload. If you wanted to say like name Scott, you can go ahead and change the payload. This particular, that's going to get serialized, or rather deserialized into, in this case, your function input object, and in JavaScript and TypeScript into basically your input context. This doesn't actually require any kind of an input payload, so we'll go ahead and leave that the way that it is. And instead what we're going to do is just go ahead and debug this. And what's going to happen is it's going to tell us, hey, your function's not running. Do you want to go ahead and run it? And it's going to prompt us for how it should be run. Now these are all the parameters that get passed to the CLI that does this, and primarily the ones that you're going to want to focus on to start are going to be the HTTP port that is used for actually making calls to your function, the remote debug port that the remote debugger will be connecting to. If you need any additional name value pairs, basically environment variables passed into your function, you can establish them here. Some additional configuration for how the Docker container gets created and set up, and the level of logging you want. We're going to go ahead and just take the defaults and let it execute. We'll see an example in just a moment of when you would not only not want to, but not be able to take the defaults. And so what it's doing now is using the CLI to create, to populate the Docker container. And so it is downloading kind of base images, layering those so that it creates effectively the operating system image that it wants. It will then put the Salesforce SDK, Functions SDK on top of that, and then put our own function on top of that, deploy that, start that as a server, basically as a little lightweight HTTP server that can then be invoked, and we'll look at how we can invoke that. Now, it doesn't have to do all of this each time. Iterations on this, once it's built the base image out, that gets cached by Docker. So iterations tend to be even faster. Although for a single function, this is actually not too bad. In just a moment, it should come up, and we'll see that Illuminated Cloud will actually connect the remote debugger and automatically start as debugging. You can see that it's now ready for debugging, and we'll see in just a moment. Debugger's connected, and we should see over here that it is going to execute. So it is posting, and there we have output. So we can see that our function actually just ran. Now, I said I started for debugging. I didn't set a breakpoint. So we'll go ahead and do that. We'll set a breakpoint right here, and I'm going to go ahead and say debug again. We're going to re-execute it, and we can see that the cycle time is actually much faster. So it's executing, and now we are live debugging our function as deployed into a local Docker container, and we can see that it just made a call actually to Salesforce. This is not a mocked response, and we can see that it queried an actual account. And now we can, again, because this is an interactive debugger, not a retrospective or log-based debugger, we can even change values, set conditional breakpoints, effectively debug our function executing in a pseudo live environment. Now it's live in that it's connected to Salesforce, but it's deployed locally instead of being deployed into Heroku. We'll see some differences when it gets deployed into the Heroku compute environment. Now what happens is you're evolving your function logic. How can you test your changes? Well, I'll show the quickest way to do it, and this is going to right now hold for Java, not for JavaScript or TypeScript. I'm going to keep investigating that, but the Java virtual machine, again, we'll just go ahead and add local modified date. We want to query that as well. I'm going to use this capability build project, and it will do a hot deploy to the connected virtual machine, Java virtual machine that's running in the Docker container. So we can see that that just worked. We got a nice green down here. Let's debug again, and we can see that now we're going to have, if the world's a happy place, now we should actually get back 3 fields instead of 2 fields. And we can see that we got back last modified date. So very fast cycle times when you have access to hot deployment. You will have access to hot deployment if you make changes to Java against a locally deployed function, and you don't make schema changes or structure changes to the classes. You don't add and remove classes. You don't make structural changes to the classes, fields, methods, signatures, things like that. There are restrictions, but for the most part, if you're just like evolving your logic and testing it, it works really well. But if I were to, for example, pull this out into a function and say something like adapt accounts, And so what I did is just extracted that into a method. I'm just using the refactoring capabilities of the base Java IDE. And now we're to try doing that, rebuild project again. We should see red down here in just a moment. Yep, saying that the hot swap failed because basically add method's not implemented. So you need to be cognizant of what's available here. This is what I do all the time when I'm building Illuminated Cloud, and effectively you get into the habit of building out a skeletal structure of what you need and being able to effectively change your logic in place. Now, if we didn't need to make a true structural change, all we need to do is go back to our Salesforce functions and say redeploy, restart the local Salesforce function. And what that will do is just rebuild it, redeploy it, reconnect the debugger, and put us right back into it. And so let's take a look at how that works. Hopefully you can get a good balance there. As I alluded earlier, I haven't seen how you can do a hot deploy with JavaScript and TypeScript just yet. I'm going to actually reach out to JetBrains, do a little research, see if I can figure out how you can do hot deploy with those as well, because the more that you can effectively make changes and just press a single keystroke and within seconds be testing that, obviously the faster your velocity is going to be when you're doing kind of a dev test, wash, rinse, repeat type of thing here while developing these functions. So it's effectively already deployed it. Now it's just starting up the functions application server effectively, or HTTP server, and we should be connected in just a moment. We'll be able to actually go back into our more iterative cycle. Yep, debugger started. And we're connected for debugging. And we'll just go ahead and do that again. And I remove my breakpoint. Let's try that one more time. There we go. All right, and now we can step into this method because now the structural changes have been deployed. Okay, so that shows how this would work for Java. We can come back over. If we wanted to stop the function, we could stop the function. I don't actually want to do that. I want to create another function. So we'll create a JavaScript function and go ahead and let it format the generated source files. I mentioned I would show something with description. I didn't do it just a second ago. I'll go ahead and do it now. So I'm going to say OK. It's going to create the JavaScript function. It is automatically going to go ahead and run npm install the same way that it ran. It evaluated the Maven dependencies for the Java function to make sure that we have everything that we need locally in order to be able to do full development, debugging, unit test, execution, things like that here. We'll go ahead and take a look at this one. This created another directory as a peer to Java function. It created a directory called JS function, just basically the function name. And you can see that this has a slightly different directory structure based upon the different implementation language. We still have a unit test. We can still execute that unit test. I mentioned I would show where the description comes from. We'll go over here and go back to Salesforce Functions. We can see this is called a Salesforce function. This is where this is defined in the TOML file. And so what we can do is actually edit that and say a JavaScript function. And as soon as I save, we can see it gets updated down here. So this is where you can evolve some of that. But Illuminated Cloud during function creation time does try to create a nice facade on top of all the artifacts that get generated so that you can kind of configure it once and don't have to worry about where these pieces are unless you need to edit them. Now, we have this JavaScript function. I mentioned earlier that when we start a function, and we'll go ahead and do this, we'll go back over here and set a breakpoint right here after we've gotten our results and say that we want to execute this. And it says it's not executing. And so I'll say I'll take the defaults. I said there are times when you'll care about this. Well, we're already running something on port 8080. So we're going to have to choose a unique port. And notice it now says we're already running something on port 9229. So we'll choose 9230 and tell it to run. Now, that's something you only have to set up once. That gets saved as effectively a run configuration for this function, and it gets reused over time. And now what's going to do is the same thing. It's creating another Docker container for this JavaScript function, and is going to deploy it. It's going to connect the debugger to it. It's going to execute this particular function, and we should hit our breakpoint as soon as it does so. And the same thing holds for TypeScript. Now, one thing I'll say about TypeScript, though, it does not appear that right now Salesforce is publishing the source map for the transpiled files. So, you know, if you're not familiar with it, TypeScript is effectively it's not the language it's evaluated when it's run. TypeScript is transpiled or converted into JavaScript, and then JavaScript is actually executed. And And in order to be able to debug TypeScript, what happens is there's a file that gets laid down that says when you hit this line of JavaScript, that really corresponds to this original line of TypeScript. And things like debuggers like when you click on error, like stack traces and such, use that information in order to take you to the correct original source files. Maybe more than you wanted to know, but the reason it's important is if you try to debug a TypeScript function right now, you can step through the generated, the transpiled JavaScript, but it will not take you back to original TypeScript file. I think that's just a matter of publishing the source map, and then everything will work properly. I've already communicated that to Salesforce, but I just want to go ahead and put that out there as one of the current known limitations when you're doing TypeScript. I can't imagine that'll be a long-lived. In fact, it may be resolved hopefully before this feature set ships in just a few weeks with Winter 22. Speaking of that, just while we're waiting for this to come up, that's going to also be the life cycle of, or rather the introduction of this feature set for Illuminated Cloud. You know, this will be available immediately as part of the core product when Winter 22 ships, because that's when people will have broader access to functions. If there are people that want slightly earlier access to it after this demo is posted, who have access to Java functions or to Salesforce Functions, we can certainly look at that. I think the beta is effectively wound down at this point, and people need to wait until it's released in just a couple of weeks. So it may be that an early access just doesn't necessarily have value. But anyways, the debugger was just attached. It just ran our function, which we can see right here. It's posting to it. Ran our function, and we are actually at the breakpoint, and we are inside now a JavaScript-based function interactively debugging, and we can see the same type of thing. We can see that data was fetched from Salesforce. Okay, so as far as local execution, that's primarily what I want to show. Let's move on to remote execution. So remote execution takes place in Heroku in something called a compute environment, and that's all managed by the Salesforce Functions capabilities by the CLI. So we can see that there is a region down here for remote execution. Now, one thing I want to point out is as I move through functions, you won't see any change there. You'll see changes. For example, we'll stop this function. We can see it says stop, but if we move back to JavaScript function, we can see that it updates completely here in these two panels for that selected function. If we move up, you'll notice that remote execution is still there. Remote execution is for the entire project. So when I say that I want to deploy for remote execution, it is actually going to do that for the entire project, whereas local execution is on a per function basis. Just something to be aware of. And what's going to happen is it's going to bundle this up and send it off as a Heroku app to the compute environment, which has to exist. Now, there's a series of things that have to be in place, that have to be stable, that have to be complete before you can actually work in a remote environment. And Illuminated Cloud will recognize these and will help you through them in turn. Let's just start walking through. So we'll go ahead and say deploy Salesforce Functions, and it's going to come up and hit the first one. It says that this project isn't configured as a Git repository. This is a Heroku aspect. In order to deploy an application to Heroku, it has to be managed as a Git repo, and that Git repo needs to be completely committed. So what we can do is Illuminated Cloud will automatically set up our project as a Git repo and effectively begin staging the files for check-in. And so we'll go over here and take a look, and I'm going to make things easier to see, I'm going to make this effectively organized by directory structure. And we can see that we have project config files, IDE project config files. We have the actual things that were generated when we created the project. We have our source files. And then we have some other metadata management files effectively. It did generate a git ignore, Illuminated Cloud did. Generated a git ignore for you that will ensure that things that are transient, that are basically generated files, don't end up being checked into source control. And what we can do is actually also make those excludes for the project. And they won't be indexed by the project either. You know, they'll get ignored by everything. If you had an existing git ignore file, say you didn't use the empty template, use the standard template, it would instead augment that with any of these entries that were not already present. So now what we can do is just check this in. And I'm just using the IDE's native Git features here. And it's going to do a little bit of analysis. If it finds anything, I'm just going to skip it and allow it to commit, because there really aren't any fundamental issues with this. And then we'll just go ahead and allow it to commit. Okay, so let's go back over to the Salesforce Functions tool window. As soon as it says it's committed, we're good. And we'll try that again. So I'm going to go over here so you can see what happens. So here we go. It's actually using the CLI to do this, but it's going to hit another issue. So the authentication token has expired. Do I want to log in now? I have to. So I'm going to say OK, and it's going to use the browser to log in. Now, I've got the browser actually set up on another window, on another screen rather, and I'm going to go ahead and log in. Give me just one moment to enter my credentials. Now, these are going to be my DevHub credentials because I'm working against a Scratch org. If you were working against a non-Scratch org, you would be entering your credentials for that particular organization. Now, assuming I entered my credentials correctly, what we should see here in just a moment is it'll say that everything's good. Do I want to go ahead and try again? Yep. All right, so we're going to try again. We're not done yet. It's going to be another issue. Now, this is not going to be the case every time. Some of these are one-time things like setting up for Git and things like that. There's no compute environment. The compute environment is basically a section of Heroku carved off for this particular project. So I'm going to create a compute environment. Again, it's going to use the CLI to do that. It says enter a name for the compute environment. It's going to generate a name automatically based on the connection alias for this particular project. It basically appends underscore compute to it. You can change that to whatever you want at this point. Illuminated Cloud will remember that for further iterations of creating a compute environment. But I'm just going to take the default. It's a rational default. And it'll create the compute environment. And once the compute environment has been created, it says, OK, you want to try again. OK, we're there now. So it's going to basically be able to push our functions, assuming that they compile, assuming that their unit tests pass and things like that. It's going to push them into the compute environment. This will take a little bit longer than it did locally because it has to do all the functions. Now, one of the reasons that Heroku uses Git in order to do this is it can do incremental deployments based upon just the changes. So just as I mentioned with Docker deployments, once you build up a foundation, iteration becomes quite a bit faster. Now, once this deployment does complete, that process will end, and then the way that we monitor things executing in the compute environment is we tail the log there. We cannot connect a remote debugger to Heroku, at least not at this point. Maybe that's something that Salesforce will add later, but interactive debugging will have to happen through either local unit testing or local deployment testing via Docker. For deployment into a Heroku environment, it's going to be effectively executing the functions against that compute environment from Salesforce and then monitoring the logs for what happens. And I'm going to show that actually in just a moment. Well, in fact, while we're waiting for this to deploy, we can take a look at how we will do that. Why don't we go ahead and, well, actually it deployed. So we'll not get out of order here. So it finished the deployment and now it's tailing the log. This is the way that we're going to be able to keep an eye on this. We can see that it's tailing the log because this button, this toggle button actually toggled on. It shows that it is actually tailing. If we don't want to tail the log anymore, kill that process, we can do that. If we want to start tailing again, we can. We can see the same status change over here. We can see that this was last deployed, or the last deployment attempt was at this time, and it succeeded, and we're currently tailing. I can stop, and it says it's deployed, but we're not tailing, and then we can see it's tailing again. So going back to the remote execution console. So why don't we go and actually execute one of our functions? So what I'm going to do is just create a new Scratch file, Apex Scratch file, and we're just going to invoke a function. So we'll just say function, we're in Apex right now, just to be clear, function.get, and we need to fetch one of our functions. And this is another place where Illuminated Cloud is aware of kind of the relationship between Apex and your functions and things like that. Is code completion will list all the functions, the IDs for the functions in your project. So we'll go ahead and invoke the JavaScript function. And I can now use the Apex refactoring capabilities to pull that into a function, open a new line, say function.invoke, and we have to invoke, there's two ways to do this, synchronous and asynchronous. Both of them take a payload, basically your inputs for the function. For synchronous, you stop there and it will immediately return a response. For asynchronous, you pass it a function callback and that will get called back as async Apex. We're going to do synchronous. Now, when I go into this string literal, it is going to, Illuminated Cloud is actually going to inject JSON into there. So you can see that it's actually using the JSON editor for IntelliJ IDEA or for the JetBrains IDE. So it's not just an opaque string. So we'll go ahead and get our function invocation. And now why don't we just print out some information from that function invocation since it's synchronous. So we'll go ahead and print out like say get status and get response. And if there happened to be an error, we don't know if there is one. So we'll use the safe navigation operator. We'll print out the type and the message. And we will go ahead and execute this. So I'm going to say, I'm going to say execute anonymous Apex, and let's take a look at what we have here. Now we're going to get an error. I know we're going to. So it's going to say we have an authorization error. And so that authorization error is saying we don't have access to account. So why don't we have access to account? That's a standard system object. We just execute this exact same function locally. What's the difference? Well, when it executes locally, it executes using, as the user that you've OAuth'd Illuminated Cloud into. So your Docker container gets basically OAuth'd in using the same credentials, the same access token. When a function runs in Heroku, it runs as a special user, and that user has a permission set assigned to it, and you authorize that user via that permission set. So let's actually log into the org and look at that permission set. All right, so we're logged into the org, and let's go to users, permission sets, and we'll see a functions permission set. This is how you authorize that special user that functions execute as. This functions permission set. Now, Illuminated Cloud's not going to, so far it has helped you fix all the stumbling blocks. It's not going to do that here because I don't want Illuminated Cloud making changes to authorization artifacts like this. It's going to be up to you to do that. So we know that we're running queries for accounts. So all we're going to do is just give this special user the ability to view accounts. So we'll go ahead and say edit and view all. You might want to be more restrictive and just say view, so it can only be as the current user, although the current user, there's only one user. There's 9 type of user impersonation. So now that we've saved that, let's go back over here and let's execute this again. And if the world's a happy place, we should be able to see the account. And the world is in fact a happy place. And in fact, let's go over here where we were tailing the log and let's clear that. And we'll go back to Anonymous Apex and we'll run it again. And we should be able to see that we just got, we can see that just executed. We can see the actual logger. So we can see invoking JSFN. If we go back to our actual function, invoking JSFN, and then where it stringified the results, we can see it actually put out the results right here. So, so we can see how this function actually executed, and that's the way that we can monitor it pretty quickly. And by the way, if you ever want to break this out into its own window and put it on another screen, you can absolutely do that. If you want to, if you have multiple monitors, I know a lot of people do working at home or at work, you can actually take advantage of that screen real estate and get multiple views going so you can look at these side by side. All right, so remote execution kind of looks like that. And so let's take a look at what happens since we're in remote execution. If we say add another function, what else do we have to do? So we'll create a new TypeScript function. And once again, we'll just let it do its thing. So it's going to create the function. It's going to run npm install. Here's one thing that's different. Now that we have a Git repo, it's going to say, hey, we need to add these, or we can add these to version control. We need to do that anyway because we're going to have to commit this before we can actually deploy and update the Docker container. So let's just take a look at that. So as soon as this finishes, we'll go ahead and go into, in fact, we'll go ahead and go back into the Salesforce function console, and as soon as this takes care of itself, we will get this guy deployed, and we'll take a look at how Illuminated Cloud will walk you through that. All right, so I'm going to go ahead and start this deploying again, and it should come up and say, hey, sorry, things aren't committed. There we are. Files aren't committed. Looks like it added a package lock.json when npm install ran, and then basically we have our new TypeScript function. So I'm just going to say, we'll go ahead and commit that. All right, we'll try that one more time. Sorry, I get ahead of myself with everything happening. Okay, so it's going to do a little analysis again. We're just going to allow it to commit. Typically, I actually turn off a few of those. All right, okay, and so that just committed, and so we'll go back and we'll try to deploy again, and it should be able to deploy again. And so again, what it's going to do is add the TypeScript function. We haven't even made any changes to the JavaScript function or the Java function. Should add the TypeScript function and launch that into its own effectively dyno. I guess everything goes into the same dyno, but make it so that that can actually be executed as a function. And then we'll go back over here to our little Scratch file, and we will change this to be TS function, and that's the one that will execute as soon as it gets done, and then that will actually wrap up this demo. There's that cough. I actually made it pretty far. Excuse me. So while this is deploying, I'll just kind of wrap up some of the wrap-up stuff that I would have done at the end of the total demo. So hopefully this shows what end-to-end Salesforce Functions development looks like in Illuminated Cloud. It shows the support for the 3 languages. Again, your base IDE is going to dictate the level supports you have. Reiterating what I said last time, IntelliJ IDEA is going to be really required for Java development, whether it's an Ultimate Edition or Community Edition. They both support Java completely. If you want to do JavaScript or TypeScript development, you're going to need a commercial IDE. And that can be IntelliJ IDEA Ultimate Edition or WebStorm, RubyMine, PyCharm, PHP Storm. Many of those are going to work well. The one that's going to allow you to write for all 3 is going to be IntelliJ IDEA Ultimate Edition, although I think most people are going to be just choosing one language and kind of sticking with it. So that's going to be how you make sure that your IDE is paired with regard to full support. Now, you can do any of this in any of the IDEs, but you're not going to have a Java debugger in WebStorm. You're not going to have a JavaScript debugger in IntelliJ IDEA Community Edition, or very good code completion for those more sophisticated languages. Okay, so that actually just deployed. We're going to go ahead and just execute this real quick. I'm going to clear this so that we can see that happen. So we'll see this execute. We can see that it just executed the TypeScript function. And then if we go back over to Salesforce Functions, we can see that it did, and we can see, TSFN was executed. And the Java function, I guess, crashed. I'm not sure what's going on there. I know that I've seen that, and it seems to just restarted. I don't know if that's something else that's going on. JS function. Okay, I don't know. But that's all happening inside of Heroku. So this is obviously all fairly sophisticated technology layered on top of sophisticated technology, and keep going all the way down to the hardware. If there are bugs, look for people to report them. I'll take care of them as quickly as I can. If you've got ideas on how to make this more efficient, please let me know. I'm going to keep looking into how to make hot deploy work as often as possible for as many supported languages as possible in order to reduce reduce cycle time and make it so that it's as quick as possible. Otherwise, I'm really excited to get this out there. I think this is going to be huge for people developing in this ecosystem, and I hope this tooling will be huge for people developing Salesforce Functions. Thank you very much. I know this has been a kind of a longer one of my videos. Thanks for bearing with me rambling on, bearing with occasional coughing and throat clearing, and stay healthy and take care.